It's good to be here and speak with you guys today. And I will apologize in advance in that I actually, as soon as I'm done with my talk, I'm going to try to finish a little bit early for a couple questions, but I do have to run. And I apologize for that in advance. But it's great to see all of you guys out. I'm going to talk about space today. Even though what I do is a cancer surgeon, but I'm going to talk about space and future space travel. It's an exciting area, as you will see. There are lots of plans for expanding just commerce and exploration, which is very different now than when I started at NASA back in 2004. You guys are living in an exciting time, whether or not you completely understand all of that or not, because all of this is kind of rapidly developing as we speak. There's new developments happening every week. So what you see there on the right at the top is the mission patch for the crew that I flew with back in 2009, STS-129. And I've had an unusual experience and career, both as a cancer surgeon and as an astronaut. And specifically, I'm an orthopedic oncologist, which is an orthopedic surgeon that does some additional training to be a cancer surgeon. And I still hold the distinction of being the only orthopedic surgeon and only oncologist to have flown in space. And that's across NASA and other government, international government agencies, and the commercial astronauts, as you know, who have started to fly. So this is just going to be quick, but this is what I do as my day job now, as I say. And that's just a patient who has cancer in their femur bone. This is the last medical stuff I'll show you, but basically needed to have that replaced. And that is what we do, basically taking out bones that have cancer in them, replacing them, and in this case with the metal endoprosthesis is what we call. I don't see anybody passing out, so that's good. So maybe some budding surgeons in here. And this is the reconstruction, just showing the x-ray of it. But this person is able to walk on it. Not as well as with his God-given femur, but still able to walk and get around. And if you saw him, you'd have a little bit of a limp. You could, tell everything wasn't perfect, but that's the best we can do nowadays. So at any rate, I had what I call an early sabbatical going to NASA. I got selected after I started working as an orthopedic oncologist in Chicago. I was selected to be an astronaut. So what about space? Space is exciting. This is a picture of the United States taken from space. And you can see the line demarcating daytime and nighttime, sort of in the northwest of the country there. You see all the lights there from the cities. You can see Houston. Big arrow going to that. So Houston's very bright in the night sky when you're orbiting around the Earth. And when we go up to the space station and orbit around, you're going around every 90 minutes, entirely around the entire Earth every 90 minutes. So that's very fast. Specifically, that's 25,000 miles an hour, which is about 5 miles a second, if anybody wants to do the math and confirm it. But the Earth is beautiful at night. It's beautiful in the daytime too, as I'll show you with some other pictures. And I flew aboard the space shuttle. This is a picture of the space shuttle during its launch ascent. And you see the contrails behind it. This was taken by a chase plane, but it was the most sophisticated spaceship ever built. There's more on the way now, as you know, but as I'll show you, it was necessary to build the space shuttle in order to build the International Space Station, which now there's a lot of research going on as it was originally intended, and that will continue for the lifetime of the space station, which is slated to be decommissioned in 2030. So NASA has accomplished a lot of spectacular things. It's joined now by other international government agencies, but it's still leading the exploration of space. And has a three-part vision. I think that middle one for you guys' lifetime is going to be the most important, extending life to there. So getting off planet Earth and getting human beings off planet Earth and living in space. And to be accomplished by a three-part mission. And again, I think the most important one for you guys is going to be that middle one, exploring the universe and the search for life. We have to really seriously undertake that and haven't done that yet. So our ability to fly in space is intricately linked with technology and how our technology has advanced. So this is a graph of how fast we could travel. With on the x-axis there is, the years, the centuries. And the year 2022, which is not plotted there, was a very significant and important year. That blue line is commercial travel, and the red line is military and government. So 2022 is when those lines intersected, because SpaceX flew astronauts to the International Space Station. So that's a very significant moment in development of humankind, and things are only going to continue to accelerate from there. So NASA's constraints had to do with the amount of budget that they had, which has been relatively flat throughout all the years. So this was back in 2003. If you looked at the amount of the federal budget for space shuttle operations and space station operations combined per person on the right-hand side, it's less than $20 per person per year in the U.S. So we spend a lot more money on other stuff, as you can see. The defense budget dwarfs NASA's budget. And Halloween, we actually spend more on Halloween per person than on space exploration. So, and that remains true. Halloween has gone way up, as you know. I don't know how much each one of you spent this past Halloween, but it was probably a lot more than $20. So at any rate, NASA has done a lot with very little, some spectacular accomplishments, as you know. These are some of the crowning ones that everybody knows about: landing a person on the moon, people on the moon. It did happen. There's a lot of rumors and stuff in the media, which, and from famous people who I guess didn't pass their science classes, but asking whether or not we landed on the moon. So I'm here to tell you, yes, I'll swear it on the Bible. Yes, we landed on the moon. And of course, the space shuttle, which I flew on, which again, we had to do that in order to build the first orbiting space station. That's and it's been continuously occupied now for a quarter of a century. So for 25 years, there's been human beings in continuous orbit around the Earth. And again, this kind of stuff doesn't, I think, receive the kind of attention it should, because that's a very significant achievement. So NASA's motto is this: team equals success, and vice versa. Success equals team. And you've seen some movies, Apollo 13 and all this and that, with some very famous quotes. Y'all know about Apollo 13, maybe, I don't know, actually. Let's see a show of hands. Did y'all see that movie? Yeah. Okay. Houston, we have a problem here. It speaks to NASA's focus on just successfully doing these things and making sure everybody gets there and gets back safely. And with the constraints of the budget that were given to NASA, the way that they cleverly attacked this problem was that they realized that they didn't have a lot of hardware, i.e. spaceships, that they could lose. They had to really put all of their resources as much as possible into the people. And so NASA, the organization, has thousands of engineers, very smart people, who are dedicated to this endeavor in ensuring that we test every spaceship to the nth degree to make sure it's perfect, and so you're minimizing any kind of risk of any problem. But nonetheless, even with that, you still have problems which occur, and you saw all the ingenuity that exists at NASA and being able to respond to that in real time and still get people back safely, even when things go wrong. And this was the motto, and still very much so in everybody's mind at NASA, that failure is not an option. But what I'm going to present to you is that that motto has changed, and it's just because of commercial space flight. It's brought a change, which for many people is disturbing, and I'm talking about the veterans, some of the people that were at NASA from the start, where it's kind of a new way of approaching it, using an accelerated approach. And that's despite all of these challenges that you guys know very well. COVID, now we're dealing with trade wars and other wars, AI. But what we have to do, and which we've only begun to do, is this. What you see on the top is a picture taken by the Apollo crew, and that's an astronaut walking off into the landscape on the moon. And on the bottom is a picture of Mars taken from one of our robotic explorers. But we got to reproduce that picture on the top on Mars, where one of you guys is walking off into the landscape on Mars. So many people wonder, is this going to happen? I'm going to show you what the plans are for this happening. It is going to happen, probably within about 10 years or so, I think. So I think we're that close. But because of budget constraints, NASA could only do one major space program at a time. That's why the space station has to be abandoned and turned over to commercial interests so that they can redirect that $20 billion to deep space exploration and going to Mars. So a lot of people were worried, are we turning over space exploration to other countries like China or Russia? And the answer is no. It's just the way that NASA is set up is that we have to do it this way. So, as I said, the motto has changed from failure is not an option to really dreaming bigger than we've even dreamed before. And these are just some quotes about courage. And these are good quotes to see anyway. And then expertise. It's okay to have your eggs in one basket as long as you control what happens to that basket. And, of course, persistence or tenacity. Don't give up unless you're forced to give up. So anyway, this is the plan which developed, and this was, I'll show you the updated plans. When I was starting at NASA in 2004 was when this plan was originally hatched. And it's going back to the moon and going to Mars. And so you can see on the bottom there those commercial launch vehicles. So those were, in everybody's mind that was going to happen at some point back in 2004. Then we build a space station, or NASA builds a space station that's going to orbit around the moon. And that's that gateway that you see right there. Robotic explorers on the moon at that point, but you're really using the moon as a training platform to go on to Mars and beyond. All right, and the space economy is really growing in leaps and bounds. This was a slide from 2023, and we took a look at it, and it was a multi-billion-dollar industry back then. with tourism approaching $1 billion. And now, of course, that's been surpassed. I got to update this slide to what it is now. But this is one of the fastest growing sectors of projected, growth. And so, as I said, I think many of you will actually become a part of this, whether or not you know it or not. So the new culture is that you have a right to fail. And the reason is because you can actually engineer things a little bit faster that way when you have those resources. And that's what commercial interests bring to the table. So they're able to build lots of spacecraft and test them out much faster. And you've seen those in the news, some of the spectacular explosions down at Boca Chica. You might have heard it too if you were outside at the at the right time. And that's what you see up there on the right. The Starship explosion earlier this year. It was May this year, I think it was. And fortunately, nobody, died, or there weren't any injuries or fatalities there. But NASA had its fatalities too. Apollo 1, if any of you know that history, but there were 3 astronauts who perished in that fire, and that was just because they were using pure oxygen in the crew cabin, and a spark set it off. So they don't use pure oxygen anymore in aboard spaceships. It's actually 20 to 21% like we have here on the ground. But how do you manage this risk, and how has that changed over the years? Managing risk is, is a fine line, right, between boldly going, which is what you're trying to do, and fumbling on the 1-yard line, right? So it's understanding where that line is so that you don't do that. So we have to go back. We have to go back to the moon. And the moon is a fairly inhospitable place, as you can see. Surface temperature goes between extremes of plus 250 degrees in the sun and minus 260 degrees, which is near absolute zero on the dark side of the moon. And there's no atmosphere, so it's a harsh place. But that's what you also get when you're in orbit. So it's like the only difference between being in orbit around the Earth and, like I did going out on a spacewalk, these were the conditions, and the suit has to protect you from it. And being on the moon is that the moon actually has gravity. So anybody know what the gravity of the moon is relative to the Earth? Huh? Yeah, 1/6. All right. And what about Mars while we're at it? Quiet. 1/3. Okay. Yep, so here's Mars. More hospitable, much more hospitable, right? It gets up to 32 degrees. All right, you can take that. And atmosphere, it does have an atmosphere. It's just as toxic. It's 95% CO2. So you do have to be protected in that atmosphere. So the one last question I'll ask you guys is, do you know how far the moon is from the Earth? Actually, one more after that. Silence. Huh? Yeah, how far is that? 250,000 miles. All right. So how far is Mars from the Earth? He's looking it up. I see people going about 35 million miles. So it's a lot further. All right. So getting to Mars, when they're, the planets are closest together, Earth and Mars, takes about 6 months. Whereas the moon just takes you like 3 days to get there. So a lot further. So we want to go to Mars for a lot of reasons. Probably the biggest reason is because we've never been to any other planets besides Earth. So this will be momentous, to say the least, when we finally put people on Mars. We also think that Mars looked like this a long time ago, billions of years ago. It had water, had an atmosphere, and now, of course, it looks like this, cold and arid. So it went through changes over the years, and we think that there's a lot to be learned from that in terms of managing our own planet, planet Earth. We're probably doing some things right now to kind of push us in that direction too, but it'd be good to go there and figure these things out in detail. The other thing, of course, is to search for life, right? This is a meteorite that was ejected from Mars and made its way to Earth. And then looking under a microscope, you see these kinds of things like that, provocative fossils that look like it might have been like some kind of living thing, right? That's what that looks like. Maybe, maybe not. But the only way to figure that out and to really figure it out is to go there. The robotic or the robots that we send, they're okay, but they're not nearly as good as and intelligent as people. And also, aliens are not going to take a selfie for us and send it. Right? So this is kind of an updated version of the master plan, if you like. So we've got commercial people, companies providing access to low Earth orbit. International Space Station has been up there. It's being very productive now. So time to return to the moon. And that rocket you see there represents the Artemis missions. We've had Artemis 1 that was successfully done, and Artemis 2 will be next year. And that's astronauts that will go and orbit around the moon and then come back. And then Artemis 3 will actually put boots on the ground. As they say, they'll put people back on the moon. And that will lead to assembling this gateway space station, which will orbit around the moon. Just like we have the International Space Station now, we'll have a space station around the moon. And then Mars, hopefully will be ready in 2 to 3 years after getting people back on the moon. So in the early 2030s, something like that. Hopefully we'll be ready at least to send people there to, if not permanently stay there, just that's something to think about, permanently stay there, but to orbit and come back. So this is the new hardware that's going on. You see the space shuttle over there on the left, and then you see the Falcon Heavy. That's the SpaceX missions that are taking people to the International Space Station. Artemis, which is the Orion spaceship, that orange and white. And then the Saturn V, which is the Apollo missions. And then finally, of course, the Starship, which is the SpaceX. I don't have Blue Origin. Blue Origin just launched a couple of satellites to Mars yesterday. I don't know if people saw that, but I'll have to get theirs on there for comparison. But Starship is still the largest one, and the intent of it is to actually send people to Mars, as I'll show you. So anyway, that is the vision, and this is kind of it expanded. At least SpaceX's plans launched the first uncrewed Starship to Mars in late 2026. Hopefully that will occur. And then if that's successful, the first crewed Starship in, like around 2030, 2031. I think it's not going to happen that fast, but we'll see. And with the intent of sending lots and lots of people there. So how do you become an astronaut? I can just give you my story about how to become a government astronaut. But there are going to be different pathways moving forward. There'll be commercial astronauts too. So, yeah, that's me a long time ago. And this is the class I came in with, which was in 2004. Everybody has left, has retired, except for the second guy in the first row there, the second guy from the right, Randy Bresnik, who I flew with on my mission. He's the only one of us who's still in the astronaut office. So we came from all different walks of life, though. Scientists, military folks. We had some teachers. And the training that we had to undergo was over about a year and a half. And it's because you come from all these different backgrounds, but you have to be trained, of course, to fly on the spaceships that NASA was providing and to carry out the missions that NASA's doing. So the big thing is getting you to learn how to work as a team, like I laid out before. So they put us out, this was in Maine, and had us out in the woods for about a week or so running around, learning to work together as a team. The Neutral Buoyancy Lab is where we learn how to do spacewalking. So that's here, down near Clear Lake. Yeah, you should go down and see it. It's a spectacular facility. But we have to be scuba trained to be able to train for spacewalks, and that's because this is in the NBL, the short for Neutral Buoyancy Lab, and it's a gigantic pool, basically, 40 feet deep, long as a football field, and they have full-sized mock-ups of the space station and other spacecraft submerged in this. And then you go in these suits, which have been modified, and they're decommissioned from being used in space suits, and now they're used there. But you go in, you practice doing your spacewalk. And for each spacewalk that you do in space, you have to have 10 of these practice runs. These things last about, it's all day. You get there early in the morning. You're doing your run for 8 to 10 hours, and it's very demanding. This is really the most demanding training. You can see on the top right, the divers down there to make sure you don't get yourself in any kind of trouble. But yeah, the suits themselves weigh 300 pounds. So when you're getting in them, it's like a scaffold that they mount the thing on, and you get in it, and then they lower you in the water. And you're neutrally buoyant, but you're pushing against this suit and against the water, and it's really tiring. So you have to be in physical condition to do it. And then you can't eat while you're in the suit, of course, and you're in there for 8 to 10 hours. So you can't eat anything for 8 to 10 hours. You just have a little bit of water. There's a water bag in there that you can take some sips of water from, but that's it. And this is not, when you're down there, you're not down there relaxing. It's, you got a timeline you got to stay on. It's, and then they're throwing all these malfunctions in, everything under the sun. They break everything. And then at the end, when you're completely exhausted and wiped out from a hard day, they give you like some life-threatening emergency. Your crew member who's, on the other side of the pool is unresponsive. So you got to go over there, grab them, bring them back, and bring them into the airlock. So just when you're out of energy, you got to find some more energy. So it's outstanding training now. Because when you get on orbit, it's just so much easier and so much more pleasant. It's, you're just like, wow, why can't we do this all the time? So this is the jet trainers, T-38s, that we train in. And I wasn't a pilot when I went to NASA, but you become one when you're there. And I sit in the back seat because I'm not a pilot, but the people who are pilots sit in the front seat. So we had a few classmates who were pilots. And this is practicing emergency, getting out of it if you had to. Fortunately, I never had to do this for real. So the reduced gravity flight, which is a parabolic profile, gives you 30 seconds of microgravity. Dr. Haley, the other Dr. Haley, gives you 30 seconds of microgravity and flies, at least this one, it would fly 40 of these parabolas, so you get a total of 20 minutes. And basically lots of fun, makes you feel like a little kid, and this is the closest thing to how it's going to feel to be in space before you actually go. So yeah, you see the walls are padded there because everybody gets a little silly and starts doing all kinds of flips and all kinds of stuff, so a lot of fun. All right, so this is blasting off. And the space shuttle, pretty spectacular. 8 million pounds of thrust coming off the pad. And it's the first, the way to describe it is, it takes a total, and most people are surprised, it takes 8.5 minutes to get into orbit. But you're laying on your back, so it's a chair. If you take the chair and lay it down, that's how you're sitting. And for the first 2 minutes, you have those big solid rocket boosters, which you see blasting there, Roman candles. And you feel, the push in this vector through your chest. That goes on for about 2 minutes, and then those things fall off, and the rockets on the back of the space shuttle light up and keep going. And you get a little more than 2 Gs, but it's just sustained for the next 6 minutes. So for the first, 3 minutes or so, it just kind of feels like a light push. And then when you get up to about 5 minutes, it feels like maybe, like a dog sitting on your chest. And then when you get towards 7 minutes, it feels like an elephant is sitting on your chest. And you're like conscious of your breathing. I mean, you actually, okay, let me take an in breath, because you got to work to get it. And then, and you're looking at it, okay, just a few more seconds. And then, boom, the rocket shut off and everything just floats. And you come out of your chair, and because you have this quick release, it's almost like somebody pushing you out of the chair. And you're just floating. And what everybody does, and which I did too, was to go out and look out the window first to make sure it's real, So you look out there and you see the Earth and it looks like a globe, and it's pretty spectacular. I highly recommend it. So this is the crew that I flew with. The pilot and the captain are up front there. Scorch, who is on the far side, and Butch Wilmore, who recently became famous because he went up on that Boeing launch, and he was one of the astronauts that were stranded on the space station for 9 months. So he's back and he retired, but had a good time. He says he had a good time when he was up there. So that's us taking off. It was a beautiful launch. And this is what the shuttle looks like. It's you can put a Greyhound bus in the cargo bay, and so it's very large. It's retired now, all retired, but the most sophisticated spaceship ever built, because it takes off like a rocket and lands like a glider. So, and there you see it docked to the International Space Station. That gives you a sense of the proportionality of the size. Space station is the length of a football field and has the living space inside of a 5-bedroom house. It's about a little more than 200 miles above, straight up. You can see it with the naked eye as it passes, or it's just, if you go online and see when it's going to pass over Houston, you can actually see it. But you see the Earth in the background there, and you see that layer on the Earth. That's our atmosphere. So that's the oxygen that we have to breathe. So it's a finite quantity. You can actually calculate the volume of it. And So taking care of the planet Earth, of course, is very important. It's we don't know what the tipping point is in terms of when we disturb the ecosystem and equilibrium irreversibly. But anyway, this shows you why we had to have the space shuttle. It carried up a lot of those modules, and our mission was bringing up some of the last pieces that were for the construction of the space station. So here we are on orbit, and this is right after we finished the first spacewalk. The other guy I went out with is Mike Foreman. He was kind of the senior astronaut for spacewalking, the professor, if you like, of spacewalking. I was the rookie. So, and that's Butch actually getting us out of our spacesuits. You need help to get out of those things. But Foreman had done a bunch of spacewalks before. He was also an instructor at test pilot school. He's got a pretty impressive background. Now he's actually the mayor of Friendswood, by the way. So if you're ever down there, look him up. He's a really great person, and also was a very good teacher in terms of learning how to spacewalk. So what's life like on orbit? This is hygiene, of course, is important. So waterless shaving cream for those who do shave. I see some who don't out there also. He's laughing. All right, waterless shampoo. This is making the breakfast tacos on orbit and using salsa to keep the eggs from floating away. So ingenious use. And for whatever reason, spicy foods taste even better on orbit. So I liked them on the ground, but I really liked them in orbit, and these were great. We look forward to this. We've always maintained a commitment to this common mission of space exploration throughout whatever's going on the ground. So that's a cosmonaut up there cutting the hair of an astronaut who's a naval officer who's also an astronaut. But that goes on, and that still goes on even when there's like wars and stuff going on down here, like the Russia-Ukraine conflict and the Cold War. When U.S. and Russia were involved in the Cold War was when we actually built the space station with the Russians. So, space has always transcended the politics and conflict here on the ground. And fortunately, that has continued. We hope that will always be the case. So this is Thanksgiving back in 2009 when we were on orbit. And here you see the multinational crew, cosmonauts there who joined us. We had European and Canadian astronauts up there too. And they were all good sports because Thanksgiving is not a holiday in any of these countries, as you know. But they joined us for it, brought food. What you see there is the table. We tried to capture the first Thanksgiving in this country, right? But hopefully not with similar outcomes long term. Anyway, but they brought the Europeans always have interesting food, cow cheeks and all that kind of stuff. And so they have that on orbit, We just had stuff like turkey, so fancy. They have fancy stuff. So this is sleeping in orbit, and it takes some getting used to. So, of course, you guys never sleep in class, but this is no laughs. Wow, tough crowd. Anyway, this is, you get a sleeping bag and you got to lanyard it to something so you don't float around in the night. This was taken with a flash. It's actually dark in there. And then you strap your pillow to the back of your head. You're floating, it's weightless. So you're in the same situation during the daytime when you're working, floating, as at night. It's not like here on the ground where you lay down and you feel yourself lay down. So we strapped these pillows on to simulate that feeling. But it takes, some getting used to. It took me about 2 days or so to get used to sleeping in space. First 2 days, I didn't really sleep that well. But then once you get used to it, it's great. And your body gets used to it. And I found this to be some of the best sleep. And it was great. So somehow our bodies know how to get used to being in weightlessness, and our bodies actually prefer it in some ways. So anyway, you can guess what this is, right? It's not the kitchen, it's the toilet. But it works by vacuum basically, because the products have to go in one direction, and you got to potty train as an astronaut before you go, because this is not easy to use, because you see that's a small target up there that you got to make sure you get it right. It's a small target. It's not like the toilets here that are like this huge, So at any rate, this is us when we were another colleague of mine when they were getting ready to go out on a spacewalk. And I'm showing this because we have challenges. So a lot of people say, did everything go completely smoothly? And the answer is no. We had a challenge on my second spacewalk, and this was the issue. Basically, when you go into these spacesuits, you got a water bag in there, and it's water or whatever. Now they give some energy drink kind of stuff too, but the way that you actually get to drink it is this is a bite valve. So you bite down on the end of this, and that's how you suck out the fluid from your bag. So I had a problem with mine. It actually disconnected from the bag inside of my suit. So I bit down on it. We're going through our final checks. We were just getting ready to open the hatch and go out, and this is one of the final checks. So I bit down on it. This thing pulls out, and you spend all of this time, years, right? Training, getting ready for this moment. I had been on one spacewalk already, but I really was looking forward to this one too. And then this happens. And, the initial response, of course, is a lot of disappointment, because it's like, well, we can't go out with this. You got this water will be spilling inside of your suit, and could be a very bad hazard. As you know, we had an astronaut where something like that happened. There was a leak inside, and you can drown inside the suit. So anyway, we didn't open the airlock. Crew member came in, tried to get it fixed, tried to MacGyver something. It didn't work. So initially we were thinking, okay, we're not going to be able to do the spacewalk. But lo and behold, the engineers on the ground and the biomedical engineers and physiologists had been working on this thing called an exercise pre-breathe. So you go, with the spacewalk, you go into the airlock on the night before, and you're breathing almost pure oxygen to get all of the nitrogen out of your bloodstream, so you don't get the bends when you go out. So, but it takes overnight doing that. So, but they had been working on this thing that works within like an hour, but what you have to do is exercise. You get on an exercise bike and you breathe pure oxygen, and it happens much faster. So they had tested it on the ground, but it never tested it in space. So, so we became the guinea pigs, basically. And so they sent up a thing, you're signing off on this, you consent to do this. NASA's always, you got choice. And so, of course, we said yes. I mean, what are you going to do? We're up here on orbit. We're going to say no, take us home. Yeah. We signed off, and as you can see, it was successful. I'm standing here talking to you, right? But at the time, though, I had a lot of confidence in talking with the folks on the ground, the flight doctors and everything, because they have really smart people. That's how the pre-breathe works. They've done it some other crews have done it now, but we were the first. So that's one of our claims to fame, is actually validating this in space. All right, so there's, during one of the spacewalks, a crew member just took a picture of me and said over the comm, "Hey, look this way," and throw up a peace sign. So I did. We were doing construction, so this is me on the end of the Canada arm, which is one of the big robotic arms, because we had to pick up this giant tank on one side and take it over to the other side. And you can do that, of course, in space because everything's weightless. You only have to overcome the inertia. So it was this big piece of the station that I just had to go grab it. And then they flew me over to the other side of the station, I was very lucky to get this assignment because I could see everything, that perspective of seeing the shuttle docked and to the station and then seeing the vastness of space and the moon and the stars and everything. It was spectacular. So I also, because I was sitting here, when they were flying me over to get the tank, it took about 20 minutes or so. So I just went about taking pictures, and so I also set the record for the most pictures taken on a spacewalk, 357. So a lot of fun. Anyway, so this is us landing. Like I said, it lands like a glider, and this is the obligatory press conference on the tarmac, where we're all sitting there making sure we don't pass out because you're still getting used to being back in 1G after being 2 weeks in space. All right, so we've got to continue this exploration mission, and I'm going to kind of start to wind things down here. This is the communications network. It's a cartoon representation. And one of the big challenges is actually maintaining human health in space. This is a cartoon representation of some of the major changes that occur. I won't go through all of it, but probably the biggest one is radiation doses that we got to mitigate in sending people to Mars. These are medical conditions that commonly occur in low Earth orbit, and that's back pain and musculoskeletal injuries. So as an orthopedic surgeon, it was, I felt very like I had a lot to contribute in terms of looking at these things. And these are some of the hazards of space flight. Radiation, again, I think is the biggest one where we really don't have all of the mitigation that we need, and we're going to need to do that. And that's because when we're going to Mars, it's this ionizing radiation that's the risk. So solar particles and geomagnetic radiation, those things, also cosmic rays, we have to protect against those things as we venture out. This is me on the flight deck. I was also the medical officer or crew medical doctor. And the big thing in going to Mars is how are we going to do surgery in space? We can do surgery on inanimate objects, so we got to figure out how to do it on people. And the reason why this is a challenge is because of the communication between the Earth and Mars. This is kind of showing you the communication delay and how long it takes to get a person back. You see up there on the space station, essentially no communication delay, but it takes 3 to 4 hours to get a person back. If you go down to Mars down here, 40-minute communication delay. So, you send a message, it takes 40 minutes to go there and come back, 40 minutes round trip. And 6 months minimum to get a person back. So we got to be able to do surgery. I'll skip this, but there's lots of surgical issues. So one of the places where we've tried to figure out some of these strategies is the South Pole. This is on the station on the South Pole, and there was one of the scientists there needed a knee scope, and there was a doctor there who was not a surgeon who was the only doctor there. So basically, they had an anesthesiologist at Mass General to walk him through a spinal anesthetic, and then an orthopedic surgeon in Denver to walk him through the knee scope. So everybody survived, and the patient actually did okay. This is transatlantic robotic assisted telesurgery. And so the patient was in France, and the surgeon operating the robot was in New York. So he did a cholecystectomy transatlantic. So we can do these things. Patient left 2 days without complications. So, all right. So this is the goal. We're not there yet, but we're getting there. And this is, commercial space flight. I'm going to speed up because I know our time is almost done. This is a picture from Artemis mission. And here is the most updated timeline going to Mars with, prominently featuring this ship, Starship being built by SpaceX. And it has this feature of it needs to be refueled in orbit. So that's really the key to doing all of this. All right, so I'm going to finally close out here. I know you guys got to go. They got to go to class?
If you have class, if you need to leave, if you have class, you can do so we understand.
Yeah, just go.
If you have class, please go ahead.
Yeah. So, but what I want to show you is that we got to go to another planet, and the first one is Mars. So this is a size perspective showing you Mars in front of the Earth, and it's about 1/3 the size of it. This is Earth and Jupiter, and you see Earth is much smaller than Jupiter. And this is our sun, which is a small star in the galaxy, and you see Earth is just that little dot. This is an average-sized star, Arcturus, and you see it's much bigger than our sun, right? And Jupiter is almost invisible at this. And this is a big star. So our sun is just like a little dot compared to Antares. So when you look at this, which is a representative, a galaxy that's kind of similar to ours, you realize just how small we are in the universe. We're invisible at this scale. And so you look at all those other dots in the background, those lights, those are not individual stars, those are actual galaxies. So if you magnify, this is what you see. This is a deep space view. All those are other galaxies out there, not individual stars. And so this is some numerology, 200 billion galaxies. That's just our best guess. 100 billion stars per galaxy, and this is for the universe. And about 10% of stars have planets. So you get this number of planets if you do the math. So, yeah. Exponent 21, all right? So when we go to Mars, that will be 1 that we've been to. So you can take this number and subtract 1, and that gives you some understanding of how little we've done so far. We've done nothing so far. So basically, we have to be about the business of exploration and get serious about it and get ourselves under control so that we can actually do it. So that's it. Sorry to run over.
Let's open it up for a couple of
Dos Equis, 2 questions.
Yeah.
Why do you think you got selected by NASA?
It's partly, I don't know specifically because it's a selection committee. It's what they look for. Nowadays, they want you to be established in your profession. It's got to be something with math, science, engineering at NASA. That's not true of the commercial flyers, but at NASA, that's what it still is. And it's because they're focused on exploration and kind of pushing the boundaries. Now, for the commercial, they're looking for different things. So they're looking for people that can write stories, sometimes artists, more with a foot in the humanities, so that they can tell the stories of what it's like to go into space. So, and that's going to open up a lot more. So, yeah.
So you talked about how with different governments in space, the astronauts can collaborate with each other. Is there a concern with space travel going towards more commercial that there's not going to be like a collaborative spirit among astronauts and cosmonauts?
That's an outstanding question. Will there be a collaborative spirit? We hope so. I mean, we don't know. This is uncharted territory, and the influences for companies are different. They're answering to shareholders. Probably the only thing that gives us insight is the history of this country. When they sent settlers over here, these private companies, settlements initially, and there is a lot of not a lot of unity, I would say. So it may be the same thing. We'll see. It could be ugly before it gets pretty. So okay, one last question. Yes, sir.
So, as a pioneer and trailblazer in this space travel experience, would you, if you could choose to be born in a future century where we are constantly going to Mars and maybe even other habitable planets, would you rather be in that type of world and universe where we are constantly traveling, or rather you choose your experience of going to space?
All other things being equal, I think I would rather be in the future because things have gotten better. I don't know if you've gone and looked at some of the things about the early settlement in this country and everything, and I wouldn't have wanted to be back then. I'd rather be now, and I think things will continue to get better, hopefully, in the future, and the technology is definitely going to advance. So it'll be possible to do these things and see some things that now we just don't have the ability to see, go places we don't have the ability to go, and that's exciting, So I think you guys are going to get to see more than I got to see. And yeah, so, okay, thank you.